Okay, we're gonna start today by going over your homework. I heard a couple of people ask me for a refresher on how to do these ones. The ones where they did not give you the temperature or the wet bulb temperature. If you recall when we went over these on Friday, I said you got to work with what they gave you. So they gave you, in this case, they gave you both the difference and the relative humidity. So you work with what they give you. They give you the relative humidity. So I know I'm going to be on this chart. They give me the difference. So I have a difference of 5. So you find 5. You go down until you, again, you work with what they give you. They give you a relative humidity of 58. So 5 and 58 happen when there's a dry bulb. So 5, 58 gives me a dry bulb of 20. So you can fill in the dry bulb of 20. And then you can go 20 minus what gives you 5. Remember, this always has to be colder. So 20 minus 15 gives you 5. And then again, you can use the 20 and the 5 to find the dew point. 20 and 5 is 12. So always just work with what they give you and you'll be able to figure out what's missing. What? What do you mean chose different? You can't choose different numbers. 10 and 5. No, you can't pick the numbers. You have to go with what they gave you. They give you a difference of 5, gives you a relative humidity of 58. So you can't pick, you have, because that wouldn't give you a humidity of 58. So let's do the next one down, just to make sure you guys get it. So we have a difference of 8 and a relative humidity of 33. So difference of 8, follow the 8 down until you find 33. Right there, follow that over, it tells you 18. So now I know the dry bulb temperature is 18. 18 minus what gives you 10? 18 minus what gives you 8? That's 10. And then you fill it in, 18 and 8 again. 18, oh, this one, sorry. 18, 8. Looks like 2, but I'm going fast. Yes, 2. So you can't just pick, you got to go with the only thing that gives you that relative humidity. All right, let's fill in the rest of these then. There we go at the top. 16, 9, 7, 1, 37. 20, 12, the difference is 8, and you get 4 and 36. So check your work. If you get these wrong, I want to go over them for you. 4, 0, -7, and 42. 10, 7, 4, and 65. 26 is 15, 11, and 28. We've got -10, 2, and 41. 17, 11, 9. -4, 4, -15. 18, 15, 81. 24, 6, 30. We did these two already. And then you get 4, 10, 63, 24, 24, and 92. 3, 0, 71. And finally 1, -13, and 68.5. Are there any there you want me to go over? Did you get any wrong? Yeah? Which ones did you get wrong? Brad, tell me which one of the ones you got wrong.
I got the
What was the dry bulb number there?
dry bulb number would be like
The one that's which one? There's a couple of them.
the one that's like right below 0.
Right below 0. Okay, so again, we work with only thing they gave us was the 16 and the 2. So they told us that. So from that, we can get the dry bulb. What minus 16 gives you 2? So 18 minus 16 gives you 2. That part, I'm hoping you guys can figure that part out. I can't really teach you that. That is like elementary subtracting. Was that the problem? Maybe. Did you get 18 there?
Yeah.
You did? Okay. If you got 18 there, then you got the easy part right. So then we just remember that you want the dry bulb and the difference, not the dry bulb and the wet bulb. So 18 and 2 for the dew point first, 18 and 2 should be 15. Hopefully that's what I put. Yep, it was. Did you by any chance do 16? Did you have 16 as your answer for the dew point? You did. All right, I know what you did wrong. You counted, and if you're counting over to get to 2, what's this first number? 0, 1, and 2. So you can't just count over 1, 2. You have to go 0, 1, 2. That's what you did? Okay, so don't do that again, you two. Hey, Brad, if you're gonna count, go 0, 1, 2. Okay, that makes sense. That is a really easy mistake to make. Okay, I'm glad we figured out your mistake. Did anybody else get some wrong and you're not even sure what mistake you made? Cynthia, which one did you get wrong? The 16 one? Did you get the difference right or wrong? Okay, so we know 16. Ooh, did you do 16 and 9? Did you have the answer of -6 for your dew point? Instead of 1, you had 1 for that? So that was correct. You got the relative humidity wrong. So let's see, 16. Did you have a relative humidity of 21? Oh, I can see, that's exact. You did the same thing. You counted. Instead of going to 7, you went to 6. So you counted 1, 2, 3, 4, 5, 6, 7. Or you just, your eyeballs. Okay, so I think I said this on Friday. The easiest, what I don't want to see, I literally want to see you do 7, what was it, 7 and 16. Bring your fingers over till they physically meet. Okay. Yep. Okay, that makes sense too. So just, you got to take your time with this. It can't be something you rush through or do with blurry eyes, I guess. All right. Anybody else willing to tell me which one they got wrong so we can figure out what you did wrong? Most common mistakes are well, one thing you guys didn't mention is just using the wet bulb. So be careful. That is probably the biggest mistake. You forget to do the difference, you do the wet bulb. But the second biggest is what Brad and Jake and a couple of the other did. Remember, 0, 1, 2, 3, 4, 5, 6, 7. All right, so that's that. As I said before, your homework is going to be these 5 questions is only part of your homework. So you might want to jot this down. This is homework. So it's word problems. These will be more like they're written on the regions. And I will point out here, it says, what is the relative humidity if the dry bulb temperature is 20 degrees and the wet bulb depression? I've never used that phrase. Now they tell you what it means. It means the difference between the wet and the dry. So wet bulb depression means how much was the wet bulb depressed? In other words, how much did the wet bulb go down? That is, again, the difference. So you don't have to do any math here. They already tell you. They tell you the dry bulb and they tell you the wet. The difference is 6. So no math involved. 26, bring your fingers together, done. That's part of your homework. And as long as we're at it, I'll tell you, this is the rest of your homework. What? I couldn't hear you. Oh, okay. Well, it's only 6 things. You can handle it. Well, yeah, 6. So let's do the first one together. So first about the directions, say, state the relationship for each of the following variables, draw the graph of the relationship and label the graph and explain why. So as temperature increases, air pressure, I want to know, does it increase or decrease? So wait, don't say anything out loud. Let's work through this together. Air temperature. So if it increases, we're talking about air temperature getting warmer. What do you guys know about warm air? Okay, it's hot. And what does hot air do? Hot air rises. Think of a hot air balloon. A hot air balloon rises, going up. So, but I don't care about where it's going. I care about pressure. When do I get high pressure? Think of this. Pressure is the amount of what? What is air pressure? Amount of air pushing down. So if a hot air balloon is rising, are we going to have a lot of pressure on us or less pressure on us? Think if it's rising, less, because if something's cold, then it's sinking and pushing down on you. But if it's warm, the air is rising. So I like to think about cold air sinking. I hate thinking about warm air rising. I think about cold air sinking, it's pushing down on me. So if it's rising, it's not pushing down on you. So how can I say this? As temperature increases, what happens to pressure? It decreases. So review from chapter 1. What goes on the x-axis then? Temperature or pressure? Temperature is always what goes first. Always what's on temperature here. Pressure here. Which way does the line go down if it's decreasing? Now you have to explain why. So what can we say? How can I describe that there's I just did a little dance up there for you. How can I put that in words? Nah, not just Cynthia. I want the rest of you, not Victoria either. Thanks, Victoria. Saw you thinking. How about the rest of you? Cole's done a bunch today. How about the rest of you? Guys, how can I put into words why as temperature goes up, pressure goes down? I just stood up here. No, not Jake, you've been thinking a lot today too. Come on, guys. What did I just say? I'm just gonna call on people and ask you questions then. Somebody want to volunteer before I start calling on people? All right, here I go. Lily, what does warm air do? No, it doesn't. Connor, what does warm air do? Where does it go? Up, right? Up in the air. Warm air rises. Guys, picture a hot air balloon. Which way do they go when they turn on the fire? Up. So when hot air balloon is rising, is it pushing down? No. If it's going up, it can't push down. So what can I say? Warm air rises. Okay, that's not talking about pressure yet, though. What can I say about warm air rises and pressure? So why does the pressure go down? Because the air is, okay, so warm air rises. So it's not pushing down. So, okay, now you have 5 more to do for homework. You have a total of 10 questions for homework. You will have to tell me. I will be checking tomorrow for increase or decrease, or stays the same for the record. Labels and a drawing and a reason. So there are 5 questions left. I'm looking for 3 things each. This one will be worth 15 points. And there's 5 questions here. That'll be worth 5 points. Tomorrow's homework's worth 20 points. You got this. All right, I'd like you to turn back to page, that looks like page 33, please. We've already done everything I want on 33, despite the fact that mine is blank. We've already filled this all in. But I want to make sure you know something about dew point temperature that I don't think I covered yet. So first of all, somebody remind me what dew point temperature is. Ted, on page 33, what did we write for dew point temperature? Were you here for that? Yeah, you got it, Jake.
Isn't it where the temperature at which the water comes out of the air?
Yep, so it's the temperature at which, so you can add this if you don't. Guys, what's one example of water coming out of the air? Rain. If you have room, can you write that? If you don't already. So rain, snow. What are some other examples? Rain, snow, sleet, what? Frost. I don't have room for all these. I've been getting at fog too as another example. Anytime water is coming out of the air, it is an example of, so when the water hits, air hits its dew point and water comes out of the air, what I'm talking about is rain, snow, fog. Anytime there's water droplets, that is when water comes out of the air. So I just want to make sure that you understand this concept. So what about, so we're adding at the bottom, when temperature and dew point are close. What's going to happen if temperature and dew point are close? Not nothing. What happens when they are the same exact temperature? Let's go like that. Temperature and dew point are the same exact temperature. What's happening? Brad, read the definition again. So if temperature and dew point are the same, guys, what's happening? Kendra, can you get it? What's happening if temperature and dew point are the same? So if they stay the same, what's going to happen? You're right. Water's going to come out. So if temperature and dew point are the same, water's going to come out. So what if they're really close? Not the lotto, because it's not coming out yet. What happens if they're close? They will squish together. What I mean is precipitation is likely. Yes, that's what I'm saying. It's about to rain. If temperature and dew point are getting close, so the closer these two, the more likely it's going to rain. You saw that, right? That was really impressive. I know it just, it looked like I threw it, but I didn't. I could never do that again if I tried. Yeah, it must. So I went like this and it. All right, so what I want to keep going with this same ideas, and I want to turn over to page, no, not 35, because we already did 35. You're getting, that's your homework at the bottom. I want to go to page 36, which starts with condensation. So actually, that was my next question. Hang on, Jake. So my question was going to be, you guys have heard the word condensation before. Has anyone never heard that word? You know what it means. Tell us what it is or what it means. I think you do too. I'm pretty sure you do. You do know.
I don't want to say.
Say it.
I'm gonna be
So it's okay to be wrong. This is a safe place, I swear.
wrong. Okay, so then like, for example, like, if you have a cold drink, it's like warm outside.
Yes.
And water starts going down the side of it.
It is the perfect example, Connor. So let's do that in example. We're skipping the definition first. We're going with examples. I call that sweat on, we'll call it a water bottle. Because that's what Connor started with. So, no, there's a line at the top. We're going back to give the definition in a second. On a hot day. I don't think any of us have sweaty water bottles today, do we? Unless somebody's got a really cold, is yours sweating? No. If they were really, really cold water bottles, they'd be sweating right now. But I don't have any ice cubes. Nobody's got ice in theirs? All right. If we had ice cubes in them, they'd be sweating. What's another example? So Connor's got one perfect example. It's legit the first one that I have on my PowerPoint too. So you did know it. See, it was safe. What are some other examples of condensation? None? You can't think of anything?
I don't really think that.
It's not when it evaporates. It's in fact the opposite. Okay, so our bodies being sweaty is different. So that is our body producing a liquid. So it's not just the air condensing on our. Yeah, ice cubes in your lunch, and then you might get some sweat situation in your lunch. Yeah, you got soggy. Windows, what about windows? What?
Isn't it like when it's like really humid out or whatever, but when you see like soap? They're kind of like that. Or when you breathe on it.
This time the smiley face disappeared. Must have did it at a different spot.
You should, you should.
Please don't lick the window over here, okay? Can you please not lick the window over here? Okay, good. All right, so yeah, I didn't breathe on that one. So that just not right here, okay? So what did I just do? So Hayden, walk me through this. What did I just do to make that fog? Put hot air on it. And since you guys haven't lived under a rock, how's the window feel?
Cold.
Cold. Hot air, cold window. Hot air, water bottle, cold water bottle. They don't, well, they do, they create fog or sweat or water droplets form. Can you guys picture another time when things get fogged up? When you take a shower, a car too. When you take a shower, perfect example, what's going on in the shower situation with the foggy mirror? Hot water in your shower makes hot air, hits a cold mirror. Chloe, do me a favor. Touch your desk. Chloe, remove your hand. What's going on? There's a hand grin. How many of you guys have sat at those back tables?
I hate it.
Yeah, you're like, and then you're like, oh my gosh, my hand's so sweaty. How many of you done that at least once? Well, believe it or not, it's happening on these desks too. You just can't see it. Just shows up nicely on the black. So Chloe, were your hands that sweaty? No, they're not sweaty, and mine aren't sweaty at all right now. I do not have sweaty hands right now. But I totally leave a sweaty looking handprint. It's not sweaty handprint. Sorry, I didn't mean to embarrass you if I just called you out on having sweaty hands. You don't have sweaty hands. What's happening? Why is Chloe's handprint showing up? Hands warm, desks feel cold. So any moisture that was in the air is now condensing on the desk. And like I said, it's happening on these light colored desks too. You just can't see it. So what is the common denominator for all of these examples? Hot and cold. Remember how we had these two different buckets or containers, I guess. Remember that hot air can hold more moisture than warm air. Does anybody remember why? Not just because bigger. Why do I represent it with a bigger bucket? Because it holds more, but why can warm air hold more? spreads out. The molecules are spread out, so there's room for moisture in between them. Cold air, remember, they huddle together. There's no room for moisture. So what happens? And again, it's not happening on my, let's go over to the window. We've got this warm air floating around. Actually, it was warm air in my breath. I take it back. I got warm air in my breath. I breathe it on the window, and what happens when it touches the window? But why did it get fogged up? Because the window's cold. I've got the hot air coming out of my mouth. That one was able to hold this much water. Yeah, when you go outside and you breathe, you got your hot breath going into the cold air. Happens when you guys have glasses on, your glasses. If you go from this happens 2 different times. If you go from warm to cold, or the other way around, if you come out from warm outside into a cold air conditioned room, they will also fog up. Warm air can hold lots of moisture. Cold air can't. So basically it's like dumping all the moisture from the warm air into the cold air jug. It's going to overflow. And that's the moisture on the window, is the overflow. So condensation will go up a line here. So actually, we still haven't gotten the official definition of condensation. Condensation is a change of phase from water vapor to liquid water. And so now I just want to walk you through the exactly what we just talked about, but I want to put it in words. What is condensation? It happens when warm, wet air hits a cold surface. Warm, wet air hits a cold surface, and we know that cold air can't hold as much water. So it turns to liquid water. So it all goes back down to cold air can't hold as much water, so the water drops out of the air in the form of liquid water. We're going to talk about condensation quite a bit in the next couple of days here. And the first thing we got to make sure you remember, let's talk about density of air. We actually already talked about density of air. We started with warm air. Back to when we were doing just at the beginning of class, what does warm air do? It does spread apart. When does it spread apart? So warm air rises. And becomes less dense because it's spread apart. Yes, you've got the concept. Then what does cold air do? Goes down, cold air sinks because It's more dense. Does anybody remember this concept? And we learned this back a while ago. What is it called when warm stuff rises and cold stuff sinks? Hint, the lava lamp. No, that's the hint. What was happening? They'll use the lava lamp to teach you this concept. Anybody remember? Begins with a C. No? Okay, you must know this. There's room right here to write it. Convection. You must know that concept. Again, what is convection? That warm air rises, cold air sinks. We learned it with the lava. Warm lava rose, cold lava sunk. We talked about it in water. Warm water rises, cold water sinks. And now we're going to talk about it because convection is the reason we have clouds. How do clouds form? Let's wrap today up. Clouds form. Yeah, in fact, they form because of condensation. So again, we have warm air that rises. Again, you remember warm air rises because it's less dense. It spreads out. What happens to the air as it rises? What happens to its temperature? Think about that because it spreads apart. It doesn't get warmer. When hot, sweaty people spread out, what happens to their bodies' temperatures? Yeah. No, when you spread out, you cool down. Remember, if you cuddle together, you warm up. So warm air rises. As it rises, it cools. So you got this warm air, it's going to be cooling. Now it's going to hit its dew point. We already said this at the beginning of class. What happens when air hits its dew point? It rains, or at least water droplets form. You're right. And then we have clouds. Those clouds are nothing more than what I just breathed on the window. And two-ish vocab words. To go along with this, we need to know the word adiabatic cooling. I know. Adiabatic cooling, A-D-I-A-B-A-T-I-C. There's an adiabatic cooling, probably one of my favorite earth science words to say. It's just fun. Adiabatic cooling. Yeah, well, it can be fun for you to say, even if you only say it for 1 year. Adiabatic cooling. You don't think it's as fun to say, Ted? No? Okay, maybe it's me.
Yeah.
Okay. All right. All adiabatic cooling means it's a fancy word that air cools when it rises. So air cools as it rises. I could have replaced warm air rises as it cools, or as it rises, it cools. I could have replaced that with adiabatic cooling. And then one more time, in case you already don't remember it. What is dew point?
Whatever.
Yeah, temp at which water droplets form. And that's it. like I said, you have homework page 35 and 37.
36.
37.